Hello, this is our design video for our project. This is John.
I'm Peter.
And Carl here.
Yeah, just to remind you, the general idea for our project is to build a battle bot to compete with Group 10s, where the competition is going to be 2 rounds, where the first one is going to be an autonomous balloon popping competition, and the second one is going to be a remote control close combat battle. And the goals would be just a robust design as well as lethal weapons to maim the other group.
So you want to talk about the chassis,
Yep.
Carl?
So I'll start here. Here's what we have so far. We have altered the original chassis, which I can show some CAD drawings of here.
Give me the phone so I can try.
So this was pretty much what the original chassis looked like. If you see the screen here, and then I can move to. This was our intent. Oh, okay. And then this was just a rough sketch of the chassis without any of the mechanisms attached. We just wanted to at least plan out how we would mount the battery and protect the tracks a little bit, and then have space to mount everything else in. So this we had this done before coming in here today, and so we went to pick up the aluminum here, and we were able to fabricate all the extremities for the chassis. So we added these 2 main rails here out of 80/20, and this pretty much combined with a sheet metal base formed the main chassis of our robot.
This is the sheet metal base, right?
Yep, right here. And then we knew the battery is the most integral part of the robot. So is at least the center of mass. So we tried to keep it in the center and use these L brackets to keep it in place there, and trying to reduce the amount of fabrication we had to do was just use the same holes, the same measurements, and just try to keep everything as simple as possible. And that included the rest of the defensive, just shielding of our robot. And so that's pretty much it for the chassis. So now I'll talk a little bit about the first mechanism here, which is the thwacker, as we refer to it.
Mm-hmm.
So we were struggling at first to figure out how to actually activate this, because it's going to start in the upright position. So we knew we had to use some sort of motor to activate it, but we couldn't. We just don't have the machines here to fabricate some sort of hole for that will fit any of the motor drives. So then we decided on a drawbridge, sort of string tension device, so that we will use a stepper motor to control the actual activation of the device here. So we have the stepper motor here actually turning with an Arduino code running from our Arduino that's currently off board.
Yeah, so this is the code that we wrote. It's just turning the stepper motor, and obviously we will program this to be the right amount of rotation once we get it working.
And it'll be some sort, we'll have either a button command or an autonomous trigger for it to.
Which is the 3D printed thing as well.
Yeah, and we'll have some sort of 3D printed pulley on it that will be able to fit onto this motor shaft here, and then we can connect the string from
wrap it around.
Yeah, sort of something like this, but a much more functional design, and get a little bit more torque out of it as well.
And this is the actual design that we did. So we have these L brackets here, and we stuck a bolt through here with some washers to keep it steady. So it just rotates freely, and we have a mechanical stop here, and it mechanically stops going backwards as well. So yeah, and when the robot's moving, this will be sticking up. held by the string, and then the string will just let it fall when we need to release that, and then the stepper motor can pull it back up. Okay, so that's our first subsystem, the mechanical overview of that. The second subsystem that we're going to talk about is the gun. So this will be done all autonomously, but basically what we have here is, this is the whole mechanism. It's, did you upload the code?
Not yet.
Don't upload the code, yeah. So basically we just took a gun, hot glued a servo on top, connected a zip tie to the trigger so that when we either press a button or whenever the robot needs to, it can actuate the servo, pull the trigger, and fire the gun. We're just going to mount that here. We're going to have to pull this mechanism ourselves to cock the gun. So we're only going to get one shot autonomously, but the gun can fire autonomously whenever it needs to. And yeah, so this is going to be for the first challenge. So if we want to, we can press a button to shoot the gun, but the robot should be able to do it itself. So if we upload the program, obviously it's going to take me a second to reload, so I'm only going to fire it once, but as soon as we upload the program, the servo will actuate the trigger and fire it. 1 sec. There we go. Should be happening soon. There we go. And that dart is probably long gone.
Note that this would be using a pixie camera to sense their balloons, and then with some further computations, we could definitely try to predict where their vehicle is going to go and shoot the right trajectory to hit their balloon.
We'll talk about more of that in the robot operation workflow, but yes, so we haven't mounted this gun yet, but it shouldn't be too hard to do. We'll either stick some foam in there and screw it in, or hot glue it maybe. And we also need to make sure it's lined up the right way, so that's probably going to depend on what the other team's robot looks like, so maybe we can get a sense of that before we make a final decision on exactly how to mount this. But it fires, and it's going to keep going, obviously, because we put it in a loop, but we can stop it anytime. Okay, John, you want to talk about the third subsystem?
Our third task is the disturbance system, which is going to attempt to kind of mess with their sensors. And the two sensors that we want to name specifically are their ping sensors and their pixie camera. And we see that we have some simple code to blink some LEDs, and later on they're going to be fastened as headlights so that we could really shine some light on their robot so that we can kind of distract their pixie camera. Yeah, and for the ping sensor distraction, we're using these ultrasonic speakers, as well as we hooked up an ultrasonic function generator that we bought that will generate these signals fast enough to produce ultrasonic waves. And these speakers will emit those waves and be able to disrupt with their ping sensors so that they can't detect distance as accurately as before.
Yeah, these are just piezo speakers connected to a simple signal generator that's powered with the 12-volt battery, so that's not going to be very complicated at all. We got it working before, but you're not going to be able to hear ultrasound anyway. All we have to do is solder the connections on, right? And it should be noted that this is also part of the manual control, so I believe we can make it autonomous, but I think this is going to be round 2, where we're just going to press a button and turn the distraction stuff on whenever we want. So we can have different buttons for the different LEDs and for the speakers as well, or we can just combine them into one button, which is, I think, probably what we're going to do. And also, if we want to look at the code, we have the code for, this was the code for just blinking LEDs, basically, and then we also have the code for the shooting the gun, which just uses a servo library. Just shoots the gun every 5 seconds. Okay. So next, we are going to talk about the robot operation workflow, because we mentioned and demonstrated all the different components. We saw the stepper motor moving, the gun firing, and the LEDs blinking. So the way that this is going to work is we have 2 rounds again. The first round is going to be autonomous, where the cart's going to drive itself and navigate. And the way I believe we're going to do that is the car is going to rotate 360 degrees until it sees the other team's post-it note, which is going to be of a specific color, or possibly the balloon, because the balloon is also going to be of a specific color. And the Pixie, I guess we didn't mention this, but the Pixie's going to be mounted right here above everything so it can see in front. And we are also going to have 3 ultrasonic sensors, which we have also not mounted, but those are also pretty simple to mount. Probably just hot glue those or fasten them onto some foam. And I believe we're probably going to have an ultrasonic sensor right here on the front, maybe somewhere next to these lights, and one here on the right side, one here on the left side. So that's how we're going to navigate autonomously. So yes, we're going to rotate 360 degrees, look for the car, and obviously avoid any obstacles if there are some. When we spot the car, we're going to move towards it, and once we're within the right range, which we can detect with the ultrasonic sensor on the front, fire the gun at the balloon, which is going to be arced at a certain angle, so we have to get the right range, and we also have to get it lined up, so it's right in front of the gun. And that's basically all for the first part. For the second part, we can use some of the same autonomous navigation method to just go to the car and then like go to it and either mess it up with the sensors or lower this guy and hit it, which but it's most likely going to be manually controlled. And the way we're going to do that is we're just going to use this joystick to move the car around or something similar to this, and have some buttons, so one for lowering or raising this guy and one for turning on the sensors or something like that. And yeah, we're just going to fight the other robot by moving the car around. So the code for the joystick is not super complicated. It's just 2 potentiometers, so 2 analog inputs. But we're going to ideally have another Arduino off this car that we're going to upload the signals from these analog signals to, and then transmit them over Bluetooth to this car. So we're going to have a Bluetooth, or the module that we were given. Was it Bluetooth or Wi-Fi? The Wi-Fi module. Okay, sorry. We're going to use the Wi-Fi module that we were given, the ESP8266. We're going to have 2 of those, I believe. One of them on the off-board Arduino that transmits the data from the joystick in remote control mode, and one of them attached to this Arduino Mega that's going to be mounted on the car. By the way, we're planning on mounting that right here, and this guy, I believe, is going to go below the car, but we haven't quite gotten to that yet. So the Arduino is somewhere in the back here, so it's decently protected from anything on the front. ESP going to transmit the data over Wi-Fi from the Arduino we have off-board to the Arduino we have on the car to take commands. And there, I believe we will also have a button that if we want to switch into autonomous mode, we can, and then go back to remote control mode. That's not too super complicated. We have some ideas for that. We haven't coded anything up yet because we were mostly focusing on the mechanical design. But that's the idea. We have 2 rounds. One is entirely autonomous. One is mostly remote control. But if we want to make it autonomous, we can use a lot of the same algorithms. Okay.
And now I'll talk a little bit about the budget here. So if
Sure.
I'll show you the updated budget. We have used most of the components that were in the student component sheet. So we have our Nerf gun. We actually didn't end up using these 9-volt batteries here, but we still ordered them. But we might use them to power the Arduino if we need to do that. But then we ordered a Arduino Mega because we knew we were going to need a lot more digital pins. This motor shield that'll help us control all the different actuators we have. Then we have the 12-volt battery and the battery charger. The 12-volt battery, of course, the large one we got right there. The chassis, which was just the frame on the bottom there. And then the signal generator and the ultrasonic speakers. And that was what we ordered. And then we had a Home Depot run earlier today and got a couple pieces of aluminum L bracket stock, one in 1 1/4 inch, and then 1 in 1 inch, and we used those to firm up the chassis a little bit, and then just some 1/4 fasteners here for that as well. And now back to John for a little bit about the timeline.
Yeah, so I'm going to talk about the project management real quick. It's just going to be, we're here right now in the senior design project lab where we're working on this robot. And we're going to meet here.
My apartment.
Oh, right.
I mean, we were working in my apartment as well, and that's probably where we're going to do the final demonstration, just because we have more floor space there. We don't want to bother other people.
Mhm.
We just have more tools here, so we're working here today.
Yeah, so we're gonna work here, meet at least a few more times to finish working on this in the next 2 weeks, when our demo is. And yeah, that's pretty much it for the timeline. And then for risk assessment and mitigation, I'll give it back to Carl.
All right, and I'll just say a few things about that. So, as you can see, we have these just the foam Nerf darts. So we're not using anything sharp, a sharp projectile to inflict any damage. And when it comes to the actual robot, we're taking care to file all our corners down and make sure everything is as safe to touch as possible, because we don't want anyone cutting themselves on any metal here. That'd be unfortunate. And we're all taking the necessary COVID precautions and wearing our safety glasses when working with power tools and just machining stuff. And I think that's about it for risk mitigation.
Be careful with all the wirings as well, and make sure everything is covered in insulation and nothing is going to be shorted, or especially with the 12 volts, which is relatively high voltage. We're going to be extra careful with
we
that.
don't want to make the chassis live. That'd be unfortunate.
Alrighty. Yeah, thank you.
Yep. Thank you. This is Team 11 signing off.